Yeah, Jai Hind all. Myself Sachin Kumar. Today we are going to discuss very interesting topic that is called linked list, and particularly we are going to discuss here create operation of the linked list. So whenever we talk about the dynamic memory location allocation here, then it simple means we are talking about the linked list. Through the linked list, we can implement the concept of the dynamic memory allocation. So first of all, we are going to discuss what do you mean by the linked list here. So as we have here, this is the basically diagram to represent the linked list. Here we have the total 3 nodes here. Numberings are mentioned here, node 1, node 2 and node 3. This linked list consists of here 3 nodes. And what do you mean by the node here? Node basically here defines, it consists of basically 2 fields. First field is called here item field, and second field is called here address of the next node. So this particular field is called the item field, and this particular field is called here address of the next node. So item part basically contains the data basically here we have, and address part basically contains address of the next node. So here we have total 3 nodes. Say address of first node is 100 and address of second node is 200, address of third node is 300. Then to maintain this linked list, we need a special pointer, and this pointer is called head of the linked list. Head contains address of the first node. So our first node is here this one, and address of this node is here 100. So therefore head pointers contains 100. So through the head pointer we can access the first node, and after reaching to the first node we can reach to second node. So here this is here our the first node, and first node contains here address of second node, and address of second node is given here, this is the 200. In the same way, say this is the here our second node, and address of the second node contains address of the third node. So this is here our third node, and address of third node is here 300. So therefore next part of the second node contains address of the third node, and address of the third node is here 300. So therefore next part of the second node contains the address of the third node. So in this way all the nodes are arranged linearly, and we can access this linked list from the head pointer only. So I am further repeating how we can access this linked list through the head pointer. So first of all we need to access the head, and after accessing to head pointer, and this head pointer contains address of the first node, so we can jump to the first node, and next part of the first node contains address of the second node, so we can jump to the second node. Say at the same way next part of the second node contains address of the third node, so we can reach to the third node. So we can access entire list. This is the procedure to creation or accessing the linked list. Moreover, next point, last field of the next address part of the last node is always has the value null. So we are mentioning here null pointer here. So null means here our linked list has been completed. So in this way we can represent the linked list. Now I am mentioning here creation process, how linked list is created, what is the here creation process, how we can create multiple lists. So I am starting with creation of only the first node. We are assuming here we have only the first node. This is called here node 1, and in this way here say we are creating the our node here, and this is here our representation for the creation, and we have here head pointer and we are using here this structure for the creation purpose. This structure basically contains here two fields. First field is called here item. This item part contains the data part, and we have here next pointer. This next pointer contains the address of the next node. So this is required for the linking purpose, and we need here 3 pointers. 3 pointers are required to create n number of nodes. So therefore, we have here total 3 pointers, and through these 3 pointers we can create n number of nodes, and head pointer always points to the first node. This is here our the first node, and how we are creating the first node. To create any node we need here malloc function. So with the help of the malloc function we are creating the node. So when this particular function, this particular malloc function executes, one node is created. So after executing this particular code, this particular node is created, and we need to pass various values of this particular node. So we need to pass here 2 values. First value is here item part, and second value that we need to pass is, this is next. So we can pass here these 2 values using p arrow item. So p arrow item, through the p arrow item we can pass the value to the first field. Say we are inputting value 1. So value 1 is entered here, and say suppose we have only the node 1, then linked list is always terminated by the null pointer. So suppose you have only one node, so next field of the first node should be null. So therefore we are passing here null. So in this way we can create here node 1. So this is the simplest approach to create the node 1. Now we are seeing, say if we have the total 2 nodes, how we can create it. So first node creation we have discussed in the previous slide. In this slide we are going to discuss how we can create second node, how we can create one more node. So this is the usual practice. Whenever you are creating any node, creation of the node is possible through the malloc function. So therefore we people are running malloc function here one more time. So whenever this function runs, and after running this function, one node is created, one more node is created, and address of this node is assigned to pointer q. So therefore this pointer q contains address of newly constructed node. So suppose we have here first node's address is here head, and head contains here 100, and at the same time please refer to the previous slide, p is also pointing to the first node. So therefore p also has 100. So it simple means here both head and p are pointing to the first node. After that we have executed malloc function here q, and address of this particular node is given to the pointer q. Suppose address of this node is here 200. In that case 200 is assigned to pointer q. So 2 nodes are created here, but at this moment we have created one more node, we have created the second node, but first and second nodes are not linked to each other. Moreover, we have not passed any value to the second node. So 2 more jobs are here pending. pending works are here, assigning the value, assigning the multiple parameters to the second node. So we are assigning here these parameters to the second node, and we have here very simple way to assigning these parameters. We are giving here the value to second node by giving Q arrow item. So Q means here address of the second node. So we are giving here value to the second node. Q contains here 200 and we are pointing to 200 arrow item. So 200 arrow item is here that we need to give here input, and we are giving the input. This is here 2. So in this way we can pass the first parameter of second node. Now one more parameter is missing here, and that we need to give here, and we can supply second parameter is here. Say suppose you have only the 2 nodes, then last node, next part of the last node should be here null. So therefore we are passing here null to the next part of the second node. So we are passing here null here. So in this it means here we have supplied both the parameters to the second node. Now we need to link these nodes. So linking process is here also pending, and we can also link this particular these 2 nodes by this particular line. Say here Q contains address of the second node, this is here 200, and next part of the first node should points to the address of the second node, and we can access the next part of the first node through the P arrow next column, P arrow next value. So P means 100, 100 next part of the first 100 should be Q, and this Q is here 200. So therefore we can pass this value here 200. So after supplying these values here, we have created total 2 nodes, and we have given all the values to these 2 nodes, and we have also linked these 2 nodes. This process of creation of 2 nodes has been completed. Now for the better understanding, we are trying to create one more node. How we can create here one more node? So we can refer to this particular diagram, how we can create here. So we have here further we have here 3 pointers, head pointer, P pointer and Q pointer to contains the address of the different memory locations. So we have already created node 1 and node 2 in the previous 2 slides. Now our process is start to create the third node, and how we can pass the values of third node, and how we can link second node and third node. I am going to explain these concepts now. See here, we need to create here one more node here. So we can create node here, this particular line, Q equals to struct node star malloc size of node. So in this way we are going to create the third node. So we can create here one more node using this particular line. So whenever we are executing here malloc function, one more node is created here. This particular node has been created, and address of the first node is 100, address of second node is 200, address of third node is here 300, and linking part was here 200, 300. This part basically we have completed in the previous slide. Now we have created here third node, and Q contains here address of the third node. This is here our Q, which contains address of the third node. This is here 300, and after giving here this value, P here is pointing to the second node. Say this is here 200, and head always points to the first node. This is here 100. So we need to give here values. We need to pass here different values to the third node. Basically, we need to pass here two values. First values should be one for the item part and second one for the next part. So item part is here. It should be here, using the basically here, this particular line, Q arrow item. We can pass the value for the third node. So we are passing here, and suppose Q is pointing to the third node. Item part of third node is suppose here 3, and B may give the value here like this. After it, we need here the linking process. Second node should contains address of the third node. So second node address is assigned in the pointer P. P contains here address of the second node. So basically we need here linking of second node and third node. So our code is here very simple. Basically we need to access next part of the second node. So P contains the address of the second node. So P arrow next means next part of the second node. It should has address of the third node so that we can link second node and third node. So very simple code for the linking purpose. This is here P arrow next equals to Q. So in this way we can link second node and third node. So after linking, say we have here only the third node, the next part of the third node should be here null. So we are passing here null here for next field of the third node. So we are writing here Q arrow next equals to null. So in this way we have created the total 3 nodes. So I have explained the concept node by node, how first node is created, how second node is created, and how first and second nodes are linked to each other, and how we can create the third node, how second node contains the address of the third node so that we can access the entire linked list. So this is the detailed process of creation of the linked list. And I'm mentioning here, say if we have the n number of nodes, or say we have the total 3 nodes, so what is the complete code to create n number of nodes or 3 nodes? So we are writing here that particular code here. So first of all, as I mentioned here, we need to make the structure. So this structure basically is defining general template, and our template is here. We have here item part, and we have here next part, and next part is basically here pointer that contains the address of the next node. So therefore type of the next should be here pointer, as it contains the address, and address is here node type, address of the next node. Therefore its type should be struct linked list, and we need here total 3 pointers. So all total 3 pointers have mentioned here, and this is here complete code to create n number of nodes. How we can create here n number of nodes here. So complete code is here written. So we are basically here further we have the 3 pointers. Initially we are giving head equals to null, because initially we are assuming that we don't have no nodes, our linked list is empty. So therefore if we have the empty linked list, so head should point to the null. So we are mentioning here head equals to null. It means linked list is empty and head is not pointing to any node. After that we have here for loop. Why we need here a for loop? Suppose we have here n number of nodes. How we can create n number of nodes? So for that point of view we need here a loop, and this loop it starts with 1 and goes up to n, and we are writing complete process to create n number of nodes in this for loop. Initially, as I have told to you, कि had equals to null. If had equals to null, so we are writing the code here. I mean, if your linked list is empty, so it means we are creating the first node. So had equals to null always executes when you have the empty linked list. I mean, had equals to null executes only in one condition, if you have the empty linked list. It means if you are trying to make the first node, in that scenario, this particular condition executes. So initially had equals to null, linked list is empty. So for I equals to 1, our condition will be true. And for I equals to 2 onwards, this had equals to null will be false. So at I equals to 1, our condition is true. I mean, initially had equals to null. So at I equals to 1, had equals to null, this condition is satisfied. So we are trying to create the first node. So P equals to struct malloc size of node. So in this way, we are trying to create the node 1. So I have also written here few lines here. That I equals to 1. We have here had is pointing to the first node and P is pointing to the further first node. So P equals to this. We have created the node 1 and address of that node is assigning to the pointer P. And we are giving the value here P arrow item. Value item part of the first node is given here, and next part of the first node is here null and had equals to P here. So what we did here at I equals to 1, we have created one node and this is here our pointer hat and this is here our pointer P. Say address of this node is 100. So P contains 100 and had equals to 100. So in this way, had equals to 100 and we are giving here value 1. We have set here, this is here null like this. So we have completed this job when I equals to 1. Now one more iteration is started. Now I equals to 2. When I equals to 2, this particular condition is false because had contains now 100. So therefore this condition is false. So else part is executed for I equals to 2 onwards. So here else part is being executed and we have here malloc function. Through the malloc function we are creating here one more node. Say second node is created. One more node is created and address of this node is here 200. We have here pointer Q. Pointer Q contains here 200 and after it we are giving the value Q arrow item as Q is 200. Item part of 200 we are giving here input. So suppose this input is 2. So we are passing here 2 here and Q arrow next equals to null. So we are passing here null. So we have given all the 2 parameters for the second node. Now we need here linking part, how we can link node 1 and node 2. So for it we have written here this particular code P arrow next equals to Q. P contains address of the first node. The next part of the first node should contains address of the second node. So we are passing here 200 using this line. Now node 1 and node 2 are linked each other. So in this way we have created total 2 nodes and after creation of the second node we can run same practice for the third node, for the fourth node or n number of nodes. So we can create n number of nodes using this particular logic, this particular here syntax. So in this way we can create n number of nodes. This is the complete code, complete explanation to create n number of nodes. So basically, if you want to create nodes at the runtime, so you can use the linked list. At the runtime, you can decide how many nodes are required. So you can take the value of n at the runtime. So you are passing here n. So basically, you can use here n at the runtime. So the value of n should be 5, the value of n should be 10, the value of n should be 200. Whatever you are passing, this particular loop executes for that number of time. The execution of loop depends upon the n. So you can create n number of nodes and decision can taken at the runtime. So in this way, you are able to create n number of nodes and you can link all the nodes. I mean, first node contains address of the second node contains address of the third node. Like this, you can link the nodes and you can access all the nodes from the pointer head. So this is the simplest explanation of creation of the linked list. Thank you very much.